Okay, dear students, I have given you enough description about micro irrigation system, and in the laboratory class I will be demonstrating you the different components which are used in micro irrigation system. Of course, in this particular board certain components have been depicted as well as it is attached. One can see that water which is pumped from the source. So in this particular board which we see, water is being taken from a well and lifted by a pump. This pump can be driven by electric motor or by a diesel engine, or it can be solar pump operated pump also it can be done. And then the water is taken from the delivery end of the pipeline. In this pipeline you find that there is one component which is used for injecting fertilizer or any other chemical along with irrigation water. Then it goes to the filter. This is a sand filter, and then water is taken. This is the inlet end of the filter. After it passes through the layer of the sand, and then the water comes out at this point, and then again, depending on the quality of water, then another filter that is known as a screen filter or strainer filter, and then from the strainer filter water is taken to the main pipeline. It goes to the sub-main pipeline. You can see here, this is the attachment where water will be. This is a ball valve which will be supplying water to the sub-main pipeline, and in this sub-main pipeline you can see this is the attachment which we call it as a grommet takeoff. So water, this particular pipeline is known as a lateral, which is attached. So here the laterals are of different types. You can see here this lateral is this could be of 12 millimeter, 16 millimeter, 20 millimeter in size, and the material of this particular lateral, it could be linear low density polyethylene or LDP, linear this low density polyethylene. So you can see here the one can attach a drain wall to drain out the water, or one can attach when we want to extend the line. So by taking this one can extend the line if someone wants to take it. So, and this part you see that inside the pipeline, lateral pipeline, this is the opening it has been provided. This is the inline type of drip emitter that is your inside the pipeline itself, and normally such pipelines are buried below the ground level, below the land surface, and water is supplied exactly at the root zone depth. This is another very the material, this is the strength of this one is less, and this is a thin pipe in which the drippers, you can see here the drip system is attached in the pipeline, and water is coming from these outlets provided. So this is a one kind of a thing. And then another interesting part that one can reduce the pipeline. Say this is a 16 millimeter pipeline, and one can reduce the pipeline. One can attach you can see here 12 millimeter, 16 millimeter, 12 millimeter. This can be the pipeline of one particular size, and then another pipeline, one reducer one can put. So when we want to extend the length of the pipeline, so at the lower end discharge decreases. So instead of taking the larger size lateral pipeline, one can reduce the diameter of pipeline. and in depending on the requirement one can take water in different directions. Different direction, if there are some certain places where irrigation is to be given, so one can take it. Now there are several components which are there, which are now it is available, which is made up of plastic. So you can see here PVC T is there available, and this is one kind. This is one filter which you see that this is one filter, and this you are seeing that this is a sprinkler system. So what I was telling you that in the drip lateral system, the drippers are attached. These drippers can be this kind of a thing where one can see that this part it goes inside the pipeline. Inside the pipeline, I can show you here. Say this is a this is known as a barb, which will go inside the pipeline, and if you open, this is the one part, and this part is a upper part, and inside the drip system, this particular tablet. This tablet is a energy dissipator. This is a energy dissipator. So water enters from this end, it comes to this end, and then here you can see the this is a labyrinth path. So water goes through this labyrinth path, which is working like energy dissipator. So water which comes in a pressure, pressure gets reduced, and then it comes out in the form of a small. It comes out in the form of a droplets, and then finally it emerges out of this. So a typical dripper, it is, you can see a online type of dripper which is available commercially. This involves three components, whereas we have at IIT Kharagpur, we have a developed dripper where we have reduced from 3 components to 2 components, and the important feature of this particular dripper that you can regulate the flow. It is a regulating, means one can regulate the flow, so one can close the completely the flow rate, or one can regulate the flow from low value to a very high value. So you can see here these 2 components, when we are keeping it out, this is like that. So this is a fully open. Now if I start closing it, so the opening is start reducing, and then slowly you will find that. So from this dripper I can get discharge from 0 liter per hour to, means 0 or no flow, to as high as more than 50 to 60 liter per hour that we have monitored. So if the plant is of high water requirement, such type of dripper it can be used, and moreover we are reducing the total plastic involvement when we have to give water to the lakhs of plant. So number of drippers when it is used, so plastic requirement and the cost of the drippers can be reduced. The another kind of a device which we call it as a inline type of inline kind of a device. Now inline type of device, you can see this is in this particular component. Inline device is inserted into pipeline, and this place you are seeing a hole. This hole basically is the outlet, so water enters. Now the device is something, the inside part it looks like this, which is inserted in the pipeline. Of course this is of a little larger diameter, this is a smaller diameter pipeline. So this is a 16 millimeter diameter pipeline which is inserted at the time of manufacturing, and you can see here the water will enter from one end, and then it goes in this zigzag path, and finally it will come out. So it will come out from this particular hole. So these, whether it is a online type of dripper or it is a inline type of dripper, these are available in different discharges. And in today's in the lab class, our aim is to evaluate the performance of online type of dripper. So we will carry out research the relationship between discharge. So there are different kinds of a dripper. You have seen that this is a turbo key, this is turbo partially your compensating type of dripper. This is a non-pressure compensating. Now when suppose we do not need water at a particular place, so there is a provision one can close. It is similar to that what I have told you, that one can close. This is a inline kind of a dripper. Online means it is inline type of dripper, but the total labyrinth path is reduced in this case. This is again the water comes from the zigzag path, inline kind of a dripper only, and then water will come out drop by drop. These are the one has to cut the pipeline, and then conceptually similar kind of thing it has been made. This has to be inserted at the time of manufacturing. Here pipe has to be cut and then joined. The lateral pipe has to be joined from both the ends. So that will become your inline kind of a dripper. Now there are other devices which are used. So one of the device, when we want to get water drop by drop, very fine mist we want to make it. So, and particularly for increasing the humidity, means the water droplets are not falling on the soil surface, but it will remain in the means the greenhouse in the surface. So it will increase the relative humidity of the air, and then water level will create the lower temperature. Now if the quality of water is poor, and then water can be given by using a drip bubbler. The discharge from a bubbler is relatively very large. It is directly fitted with the pipeline, and this part is threaded part, and then one can get it. If I want to create a small jet, and for 180 degree or 360 degree, so these kind of jets are also available. And these are micro sprinkler is the device which I was telling you, that micro sprinkler is the device. This is when the water is coming from this end, so it is fitted over this part. This particular part will go into this one, and then water will come from this end, and then this will push the water. So this will start spinning. This will start spinning means it will be spinning the water all throughout. And so when the water jet it comes, it strikes these two arms. So it finally covers, it forms a droplets. And then when we want to give irrigation for close growing crop, micro sprinklers are used. And some cases, in some time, we need to see the quality of water is poor. At that particular point also, the micro sprinklers are used. Micro jet, it is another form of the micro sprinkler. The jet will appear, it will strike here and then break into this thing. We want to flush the lateral pipeline instead of opening the lateral pipeline. So such type of provision is there. When you are closing the pipe, irrigation water supply, water will be flushed out of this thing. So there are different components. Now when we want to take out or connect a lateral with the sub main pipeline, these kinds of grommet take off, HDPE take off, it is written here, grommet take off. So practically this is the part which has gone, so this is a grommet, and then this part is connection. So this can be connected. Now it's a very interesting thing that at one point of time people were doing, using the metal they were using. So all these things have been replaced with the plastic. So you can see here, this is the HDPE takeoff or LDPE takeoff, grommet takeoff, means you are connecting with one pipeline with the another material pipeline, such type of thing. This is now poly T. We want to take the water perpendicular to the other direction. You want, and then this supply is there. You want to take the pipeline, just closing, instead of closing the pipeline, the same pipeline can be connected and perpendicular. So elbow is available. Poly joiner, when we want to extend the length of the pipeline, so one lateral with the other lateral of the same size, it can be connected. These are available in 12 millimeter, 16 millimeter, 20 millimeter in size. Reducers is also available. Just now when I was showing you the previous case, so if it is a pipeline is of 16 millimeter, I want to connect the 12 millimeter pipeline, that can, such provision is there. Goop plug, certain emitters you want to, it is not operational, you don't want to give irrigation to this thing, so one can plug the hole by using the goop plug. In order to terminate the lateral pipeline, O shape or this 8 shape, such type of things, this is there. So pipeline is coming like this. You can bend the pipeline and you can make it like this. You can see here how the pipeline it goes. So you can, what you are doing it, you are closing it and connecting this pipeline with this one. So this becomes, you are here, you can see here. So you are terminating the pipeline. So at the end, when this is the end of the length of the lateral. So if I have to flush the water, then we have to remove, and this is only possible when we want to reduce the cost of the flushing lateral. If I want to have a sophisticated system, then lateral can be flushed. This is the another arrangement. You can see the one can attach drip lateral with the tape. So one pipe is made up of LDP, another one is LLDP, and then tape has got inline kind of thing. So such provision is also there. One can connect with the arm with the joint. Tape with the poly joiner means you have a tape pipeline. So tape pipeline can be connected with the lateral pipeline. So such kind of a thing, it is possible to connect. And this is an inline filter. Now in the earlier case I was showing you that in a drip system, fertilizer or any other chemical, herbicide or even the pesticides, that can be injected along with the irrigation water. And so injection can be done by using a constant head tank, or it can be done by using the Venturi system, or by using a injection pump. Such provision is there in the drip irrigation system. I can here show you, and you will be also conducting a separate lab class on this. So you can see this component, this part of the Venturi system, Venturi injector system. This is the part which will go in the tank, and then this component, what you are doing, the water is being supplied, from one end, and then there is pressure reducing valve. There will be two pressure reducing valve, so pressure will be when you are putting it, and then this the main important part is this one, that you have a now these two ends. So one end is your inlet end, another one is outlet end, and this is the part where the diameter of the pipeline has been reduced. So area of flow is reduced, that is causing the change in the velocity, and thereby it is creating the negative pressure, and with the suction the fertilizer which is kept in the tank, it is being injected with the system. You will in order to calibrate the venturi system at what pressure it should be operated, that can be always can be done separately, but as far as the part is concerned, so this is one way of injecting fertilizer in the drip irrigation system. This is a hydraulic test bench for evaluation of drip emitters. This hydraulic test bench is meant for finding out the emission uniformity of drip emitters. So, a pump is used to collect water from the source, then water comes through a set of drip irrigation filters, then it goes to the main pipeline, from main pipeline it goes to the sub main and lateral pipeline. In this particular laboratory experiment, we have kept in the lab, where you can see the water is taken from the source. So, this is a collection tank which is a sump, and in this sump the water is stored, and then the water is pumped. So, this is the suction end of the pump, this side is the delivery end of the pump, and this pump is coupled with a small motor. Then the water is being pumped, it comes to the this delivery end of the pump, and then it goes to the lateral pipeline. So, in this lateral pipeline, this is a lateral pipeline, we have attached drip emitters. There are 10 number of drip emitters which are spaced at 30 centimeter spacing. We will evaluate the performance of these drip emitters. Now, performance, it means that we want to see how the water is getting distributed, or it is passing when so amount of water which is getting distributed in all these drippers. So, how uniform this water is being distributed, we will take the observations in a given time of water dispensing out of these emitters. So, water will be collected with the help of these graduated flask, where you can see here each graduated flask is of 250 milliliter. So, for a given time amount of water which is collected in the collecting flask, and then we will find out how much discharge it is coming out of the drippers. So, one part is to find out the uniformity. So, in the theory class we have explained you different types of emission uniformity. What happened when these drippers are being manufactured, there could be some manufacturing defect. So, there we can also find out manufacturing coefficient of variation. So, we will evaluate from the data collected from this. Then this is a very important aspect, that to classify the dripper under which category it passes through. So, we will be evaluating the pressure discharge relationship. So, this test bench has provision where we are using a pressure gauge, that how much pressure is available at the supply end of the lateral, that is at the inlet end of the lateral. Now, in this test bench one can change the slope, means when the laterals are to be laid up the hill or laterals are coming down the hill. So, in this case up to 10% means this, if you see here, this slot is made so that we can change the slope. So, when we will bring down, it means the lateral will go up the hill. So, up to 10%. So, this particular it is a of 30 centimeter this fall is there, fall in the slope, and then the other end also, if you see here, this end also there is a provision. So, if I put it on the top and then bring the lateral position at this place, that is 30 centimeter down. So, it will be again there will be. So, we can have the gradual variation in the slope, which normally it exists in the field that lateral is placed up the slope or down the slope. So, effect of the slope on the discharge and pressure relationship, this also varies, and how much is the head available at the drip emitter, accordingly the discharge will be coming out of this. So, we are now going to start the test the data which will be collected from these drippers. The operating pressure to supply water in the drip lateral is 1 kg per square centimeter, which is equivalent to 10 meter of water column. We start. Nine ml of water has been collected from the dripper. When we will collect set of these data, from these data we will find out the coefficient of discharge and exponent x.